Hello everyone, welcome to this session on the third problem or related to kinetics. So here in this particular problem, it is a block which has been placed on the horizontal surface and the mass of the block has been specified. So we shall read out the statement of the problem before proceeding to the solution. So problem statement of the problem says is, it's 90 kg block rests on a horizontal plane. So this is a 90 kg block resting on the horizontal plane. Find the magnitude of the force P. So we are supposed to find out the magnitude of force P and to give an acceleration of 3 meter per second square. So acceleration value has been fixed up. So the magnitude of the force P needs to be decided in such a way that acceleration value should come out to 3 meter per second square. And it moves towards the right hand side. That is, direction of impending motion is towards the right hand side. DIM means direction of impending motion. It is towards the right hand side. Coefficient of friction between the block and the plane is mu of k. Mu of k means it is kinetic friction. Coefficient of kinetic friction is 0.25. And we are supposed to find out the magnitude of the force P in such a way that it should create an acceleration of 3 meter per second square. Now to find out this particular value, that is nothing but the value of force P in such a way that it should create an acceleration of 3 meter per second square. So few things that we need to remember here is, first we need to draw the free body diagram. Once we draw the free body diagram, second case is we need to always ensure that, we need to take care that such a way that self-weight is always in the vertically downward direction. Then the reaction will always make an inclination of 90 degrees to the plane of contact. It is irrespective what direction the plane is, whether it is horizontal, vertical or inclined. Reaction will always make an inclination of 90 degrees to the plane of contact. Frictional force will be always opposite to the moment of the body. Frictional force will be always opposite to the moment of the body. If the body moves towards the right hand side, frictional force will be towards the left hand side. Same condition, if the body has the movement towards the left hand side, frictional force will be towards the right hand side. It is irrespective whether the body is subjected to a form of acceleration or retardation. It is independent. Frictional force will be always opposite to the moment of the body. Next comes is the direction of the inertia force, which is MA. MA is dependent upon what type of movement it is, whether it is a form of acceleration or whether it is a form of retardation. If it is a form of acceleration, it will be always opposite to the movement of the body. When it is a form of retardation, it will be towards the movement of the body. Retardation means the body should come to a halt position. So that is nothing but the case of the retardation. Acceleration means the velocity of the object will go on constantly moving along a particular direction. During that particular condition, it will be in the case of opposite direction, and this will be in the case of retardation. In my earlier two sessions, both the problems are related to retardation, wherein the initial velocity would have been subjected and the body would come to a halt position. So for that reason, both the cases have been considered as a case of retardation. In that particular condition, if we happen to observe, MA was to be given along the direction of the movement of the object. Now in this particular case, here the object is being subjected to force P and direction of impending motion is towards the right hand side. Now here this force P is constantly being applied on this particular block of mass 90 kg. So when it has been constantly been applied on this particular mass of 90 kg, it induces an acceleration of 3 meter per second square. So which indicates this acceleration is nothing but a case of an acceleration, nothing but what we are going to consider it as a positive 3. And here, in case of acceleration, the direction of inertia force shall be considered opposite to the movement of the body. And the movement of the body is towards the right hand side. So inertia force shall be considered towards the left hand side. In this particular case, direction of frictional force and direction of inertia force will be along the same orientation, that is towards the left side. So if we happen to draw the free body diagram, so free body diagram is nothing but the isolation of the body which is in contact with the surfaces and then representing all the forces acting on the body. Now forces acting on the body are 90 kg, converting in terms of weight, which is nothing but 90 kg, 90 into 9.81, that is nothing but in terms of Newton. Then force P, this force P will have a resolution force component along the vertical direction and then along the horizontal direction. Horizontal direction force component is P cos of 30 degrees. Vertical direction force component is P sin of 30 degrees. Now to counteract this particular vertical forces, there is a vertical force that will be acting at the ground location. And this vertical force is called as a normal reaction, which will make an inclination of 90 degrees to the plane of contact. So we have considered free body diagram after separation. Self weight is vertically downward. Normal reaction is perpendicular to the plane of contact. Then frictional force will be opposite to the moment of the body. Now as the force been applied on towards the right hand side, that means the body will tend to have a direction of impending motion towards the right hand side. As a resultant, frictional force will be left hand side, and this frictional force will be mu times of n, which is frictional force is equal to 0.25 times of n. So this is nothing but 0.25 times of n. Apart from this, we also need to show the inertia force. Now as stated earlier, as the body constantly moves towards the right hand side and it is a case of an acceleration, inertia force will be opposite to the movement of the body. So this is direction of the inertia force. So here m shall be considered in terms of kg, which is nothing but m is mass which should be considered in terms of kg, and that is nothing but 90 A. So this is nothing but the value of the inertia force. Now to find out all this particular force component, we need to make use of equations of equilibrium. So we need to take summation Fy is equal to 0. If summation Fy is to be considered as 0, we need to follow the direction of the forces. All upward forces positive, all downward forces negative, all right hand side force positive, all left hand side force to be negative. Now if we happen to consider here 90 into 9.81 is downward, so minus 90 into 9.81 downward, because since it is downward it is negative. Likewise P sin 30 is downward, so minus P sin 30. Then plus of n, that is equal to 0. So reframing this equation, this will be minus P sin 30, keep it as it is, plus of n. This term when it goes on the right hand side, it will be positive, which will be 90 into 9.81. So equation number 1, keep it as it is. As P and N both are unknown, so we shall keep this equation as it is. Next you consider summation Fx is equal to 0. If we consider summation Fx is equal to 0, all right hand side force positive, all left hand side force to be negative. Refer back to this particular diagram now. This is a force parallel to y direction, and it also has a force parallel to x direction, which is on the right hand side. And right hand side force component is positive, P cos of 30 degrees. Its force component is P cos of 30 degrees. Frictional force is on left hand side, minus F of F. Inertia force is on left hand side, minus of Ma, that is equal to 0. Substitute the term, P is unknown, keep it as it is. Frictional force value is mu times of n, minus of m value is 90 A, that is equal to 0. So P cos of 30, keep it as it is. Mu value is 0.25, minus of 0.25 times of n, minus of 90 into A value is, acceleration value is 3 meter per second square. And this 3 meter per second square shall be considered as positive because it's a case of an acceleration. If it had to be a case of retardation, this value had to be considered to be negative. So it shall be considered as into 3, plus of 3. So reframing this equation, P cos of 30 as it is, minus 0.25 times of n, this is the second term. This minus, when it goes on right hand side, will be positive, 90 into 3. Either you can write it as 270 directly or else 90 into 3 as it is. This is equation number 2. Now we shall try to solve 1 and 2. Solving 1 and 2. If we happen to solve 1 and 2 as a simultaneous equation, here go to mode, equation, which is 5 and 2 unknowns. First one is sine of 30, which is minus sine of 30, minus sine of 30. Next one is 1, coefficient of n is 1, coefficient of n is minus sine of 30, coefficient of n is 1. Next term is 900 into 9.81, 900, so 90 into 9.81. 90 is nothing but the mass of the object. Mass of the object is 90, so 90 into 9.81. Next term is the second term, which is cos of 30. Next is minus 0.25. Then the last term is 90 into 3. So whose value, P value shall come out to, X means P, which is 662.22 Newton. This is the value of P. Y value will be N, which is 1214.01 Newton. So these are nothing but the values of P and N after solving the two simultaneous equations. If you substitute N back in frictional force, so frictional force value will be F of F is equal to mu times of N, which is 0.25 times of 1214.01. So as a resultant, frictional force value will be 0.25 into 1214.01, and whose value shall come out to 303.5 Newton, which is 303.5 Newton. So this is how we are supposed to find out the magnitude of the force P. That means we need to apply 662.22 Newton to induce an acceleration of 3 meter per second square. And the magnitude of the reaction component force will be 1214.01. So this is how we are supposed to solve when a block is being subjected to a form of acceleration. And when it has been subjected to a form of acceleration, always the inertia force will be opposite to the moment of the body. When it is in the form of retardation, the body of the the moment of the object will be towards the direction of the moment of the object. So this is how we are supposed to solve when it is a case of acceleration and it is a kinetics problem. Thank you. Have a nice day.